Hi guys, and welcome to another video. And in this lesson, we're going to focus on alkanes. Now, alkanes form what's called a homologous series. Now, a homologous series is just a series of compounds that have the same general formula, and they also have similar chemical properties. Now, alkanes will also show a variation in their physical properties, things like their boiling point. But what I want to focus on at this point is the general formula of alkanes. And you have to remember this general formula for alkanes, which is CnH2n plus 2. Now, what this general formula means is N is represented by the number of carbons in the compound. So this formula tells us that however many carbons we have, we times that number by 2 and then add 2, and that's how many hydrogens we have. So for example, let's say that we have a compound that has 6 carbons, and this compound is an alkane. The question could say, how many hydrogens does this compound have? Well, we would first of all times the number of carbons by 2 and then plus 2. So a compound that has 6 carbons would have 14 hydrogens. Let's look at another example. What if we've seen another alkane that had 10 carbons? How many hydrogens will this compound have? Pause the video and see if you can come up with the formula for this alkane. What you should have done is 2 times 10 plus 2, and that would give us a molecular formula of C10H22. Remember, however many carbons you have, you times it by 2 and add 2 for the number of hydrogens. Okay, for this next part in the video, you need to know the molecular formula and the structural formula for the different alkanes. And you can see on the board, I've put a table with 4 different alkanes. Our first alkane is called methane. Methane has just 1 carbon, and using our rule of number of carbons times 2 plus 2, the molecular formula is CH4. Now, if we draw the structural formula, that just means the complete number of covalent bonds. Methane would look something like this. And you can see here that we've shown all of the covalent bonds in the structural formula. Well, let's take a look at ethane. Ethane has 2 carbons, which means it has 6 hydrogens. Remember the structural formula, we show all of the covalent bonds. Propane has 3 carbons. And finally, butane, which has 4 carbons, which means it would have 10 hydrogens. You need to know the structure and the molecular formula for the first 4 alkanes. Now at this point, I just want to make 2 things clear. That alkanes are hydrocarbons. We know that alkanes are hydrocarbons because their compounds contain carbon and hydrogen only. And there's another point we can make about alkanes is that they are saturated. Now that word saturated just means that alkanes only contain carbon-carbon single bonds. There are no carbon-carbon double bonds in an alkane, and this is why we describe alkanes as being saturated. At this point, just look at the ball and stick representation compared to the structural formula. The structural formula tends to show that these covalent bonds are at 90 degrees. And in real life, this isn't the case. And the ball and stick representation is very good at showing the bond angles in these different alkanes. Okay guys, thanks for tuning in. Stay in touch for another video.